Normalizing is a method that we use to bring all the variables to the same scale. As we saw previously, if a particular variable scale is large, okay, a variable has really large values and some variables have really small values, then the distance measure will be overpowered by the variable that has large values. And so the distance measure will not accurately reflect the importance of the different variables. So it is very important in clustering to rescale all the variables into the same scale, and that is done through normalization. And there are two ways in which we can do this. One is to compute z-score. Z-score will be you take each observation and subtract from the observation the mean of the variable and then divide by the standard deviation. So subtract mean and divide by standard deviation, that will give you z-score, and the z-score value can be negative or positive depending upon whether the value is smaller than mean or larger than mean. But most values will be somewhere between -3 and +3 standard deviations. So the z-score is how many standard deviations is the value away from the center mean of 0. So that's one method of normalizing all the variables to the same scale. And another approach is called range. And the range standardization is you take each observation and subtract from it the minimum value in the column. So how far away is the value from the minimum value? And then you divide by the range. Range is maximum minus the minimum. So this standardization or normalization will convert all the values to 0 to 1 scale. So if a value is equal to the minimum value, then you will have the minimum minus minimum divided by range, so that will be 0. So the smallest value will be mapped to a value 0, and the largest value will then be in the numerator, will be the largest minus the min, which is range, and divided by range. So the largest value will be mapped to a value 1, and all other values will be in between. So range standardization or range normalization will rescale all the variables to 0 to 1 scale. And we will look at both the z-score standardization and range standardization in Excel. To do z-score normalization, we need mean and standard deviation of each column. So let's set up mean, okay, average of that, okay, and then we need standard deviation, and we need to use the standard deviation of sample.s, and so now we have the mean and the standard deviation. So let's copy this across. So now we have the mean and standard deviation for all the columns. Okay, so let's increase that. All right. Okay, so now we can set up the z-score for the two observations that we have randomly selected. So here is the x value minus the mean. Okay, so now we have to copy this formula down below. So I'm going to use absolute reference here. When you copy across the columns this way, the column should change. The mean of ROR is in column D, so column should change, the row should remain fixed. So this is the absolute reference that we need. No $sign for the column reference, but a $sign for the row reference, divided by the standard deviation. Again, the same thing. You want the column to be able to change with copying and not the row. So that is our standardized value for the first observation in the first column. Copy that and across. So now we have standardized values using z-score standardization. So now we can do square root of sum xmy2. Okay, then that's your first row, first observation, and this is the second observation. So that will give us the x minus y squared sum and then square root. So that will give us the distance. So this is the standardized distance based on z-score standardization. And we can do the same kind of computation for using range normalization. For range normalization, we need range for each column. So that's max minus min. Okay, so now copy that. Now to do the range normalization, we need one more row here for min, because the formula is x minus the minimum of the column divided by the range, and we already have the range. So I'm going to insert a new row and we call this min. Okay, and then do min all that. Okay, now copy. All right, so now we are ready to do the normalization, range normalization. So for these two records, so the x value minus the minimum value divided by the range. So this way, if the x value is the smallest possible value, you'll get a 0 for the normalized value, and if it is the largest value, you'll get 1, because you'll have range in both numerator and the denominator. So the normalized value will always be between 0 and 1. So now we have to do some absolute referencing. So here we want the min to always come from the row. So row should be absolute referenced, and same here for the denominator. Okay, so now we can copy that down and copy across. Okay. Then the distance is simply, if you copy the formula from there to here, we'll get the distance. So this is your z-score distance after normalizing using z-score. This is distance after normalizing the variables with range normalization.